Hello, today I am going to discuss about eccentric connections. In last few lectures we have discussed the different type of connections, but mainly these are concentric. Now, in case of eccentric connections, the CG of the connection and CG of the load will be in different position. So, if it does not coincide, then eccentricity will develop, and because of eccentricity extra moment will come into picture, and because of that moment extra stress will come. So, therefore, we have to design the joint taking consideration of the direct load as well as due to eccentricity. So, in case of eccentric joint, we have different type of joint, like when load is lying in the plane of joint, it will be one type of eccentricity. Again, that can be designed by weld connection as well as by bolt connection, and similarly when load is lying on the perpendicular to the plane of joint, then another type of eccentricity come into picture, means another type of load reaction will come, and that also can be designed using bolt joint and using weld joint. So, basically 4 type of joints will be considered for design. Now, I will discuss today mainly on the bolted type connection where load is lying in the plane of joint. Say for example, if we see this, this is a typical example of load lying in the plane of bolted joint. So, the CG of the bolted joint is this, and the load is acting say here, say with a load P and at an eccentricity E. Then the moment, additional moment will come into picture, that is P into E, right. So, CG of the bolt joint is here. So, we have to calculate the load coming into the bolt at each bolt. What are the load coming, we have to calculate. Then we have to find out the bolt strength, and we have to see whether this is safe or not. Say if we draw this figure, we will see, say a column is carrying some eccentric load which is coming from beam or say cassette plate. So, this is column, say the eccentricity of bolt joint is this. Now, so load is acting here. Now, P is the load. So, the eccentricity will be E. So, the additional moment due to eccentricity will be P into E. Now, what will happen to the joint? In each joint we will see that in each joint there will be a load which will act in this direction, means if n number of joints are there, then load in each joint I can write say P by n, assuming that the loads are distributed equally to each joint. So, if we consider that every bolt is taking equal load, every bolt is sharing equal load, then load at each bolt will be F is equal to P by n. This is the load which is coming due to direct load. Now, another load will come because of moment developing. So, this moment, because of this moment, so this is direct load, and another load will come or stress will come in the direction, means perpendicular to this axis. So, this is the radial distance R, we can say this is radial distance. So, for this bolt there are 2 type of forces will be acting. One is called F A due to direct load, and another is called F M due to moment and axial load or direct load. So, we have to find out what is the resultant of this load, and this resultant load will be the load acting on the bolt. Similarly, for this case we will see F A will be this, and also F M will be also in this direction, because it acts 90 degree to the radial distance. So, here it will be F A plus F M, directly it will be addition, but in this case it will be f a vector plus f m vector. That means we have to find out the resultant of that. Similarly, for this case we will see this will act, f m will act in this way and f a will act in this way. So, we have to find out the resultant and we have to analyze for each bolt and we have to see which one is the most critical one. Here you see, if we take the resultant, we will see that it will be much less, it will be less, resultant will be less. In this direction, in this case f a will be this and f m will be this. So, the resultant will be f a minus f m. Similarly, for this case we can find out f m in this direction and f a in this direction. Therefore, the resultant will be this f r will be in this direction. So, for each bolt the exacted force will be different. We have to calculate the force coming on each bolt and we have to see which one is the critical. So, case to case we have to consider and we have to find out the critical one. So, if we start with the load lying in the plane of bolted joint, then we can see that. So, if we come to the case of load lying in the plane of bolted joint, then we can see that this case can be made equivalent to this m equal to p plus this one, this direct load. So, we are dividing into two parts, one is moment due to eccentricity, another is the centroid load. So, these two will be added and we have to find out the equivalent load. So, this is what I have discussed, that if we can find out the direct force, that will be F a and this F a will be simply P by N. If P is the load, then P by N will be the F a, and similarly moment we can find out, moment will be P into E, where P is the axial load and E is the eccentricity. So, if we add this direct force and moment, we can find out the combination of these. The things whatever I have drawn there, that again I have shown here, that if F m is this and F a is this, its resultant will be in this direction, we can find out. Similarly, here resultant will be just simply adding, and here we can see that this will be again adding. So, out of this 6 bolts in this particular case, we will see the extreme case will come either this one or this one, because this bolt and this bolt have similar magnitude, because the theta will be same here. So, resultant force will be same, because distance, radial distance from here to this bolt and to this bolt is same. That is why resultant force will become same for this case and this case. However, in this case it will be simply adding, but in this case we will see it will be reduced. This F r value will be less, and here it will be F a minus F m. So, it will be much more less than this, and similarly this is will be equal to this one. So, it will be also less. So, what we can see that we have to check only 2 bolts, means if we can check only these 2 bolts, then we will be able to understand which one is means what is the critical bolt, because this bolt and this bolt has same. So, we do not need to check one, means if we check the extreme one, that is sufficient, and also we have to check this one, then we have to find out the critical one. So, from this we can find out the shear due to moment, we can find out shear due to moment, that will be F m, that will be varying with r, because in this case if we see that the moment will be more if the distance is more. So, it is varying with its distance. So, F m will be more because its distance is more, but F m will be less in this direction in this bolt. So, it varies with the distance. So, F m we can write as F m varies r. where r is the radial distance of bolts from the CG group. So, what we can do? So, Fm we can write k into r, where k is the proportionally constant. K we can write as a proportionality constant. So, Fm in each bolt is coming k into r, where r is the radial distance from the bolt to the CG distance of the bolt group. So, the moment on that particular bolt, I can write moment will be Fm into r. So, Fm into r means k r into r, that means k r square, right. So, total moment, it is individual moment. So, total moment say mt, I can write total moment will be Fm into r, that means k r into r, that means k into summation r square, right. Again from here I can write k is equal to Fm by r. So, mt I can write that Fm by r means summation k r square, that means Fm by r, this is k into summation r square, right. So, from this I can write Fm, that force due to moment, will be mt into r by summation r square, that means p into e into r by summation r square. So, this is how the force on a particular bolt can be calculated from this formula, where E is the eccentricity and r is the radial distance of bolt to the CG group of the bolt. So, Fm, the force on a particular bolt due to moment, can be calculated this, and Fa we know that is basically p by n, where n is the number of bolt. So, if n is the number of bolt, then Fa I can find out as a p by n. So, this is how we can find out the value of Fa and Fm. Now, the resultant force, so we can find out resultant force, that will be Fa square plus Fm square plus 2 Fa Fm into cos theta, right. Theta will be the if this is Fm and if this is Fa, then theta is the angle between Fm and Fa. So, I can find out r, or I can write Fr, resultant force at a particular bolt, I can find out as a Fa square plus Fm square plus 2 into Fa Fm cos theta, right. Now, this will be clear if we go through one example. Now, let us go through one example. Right. So, this example let us go through. Say, calculate the shape load F that can be carried by the connection as shown in the figure below. I will show the figure. HSFG bolts of 8.8 grade with a 20 mm diameter are used. Assume the thickness of bracket as 12 mm and column used is ISWB 350. Assume no slip is permitted and slip factor has been given, that is mu f as 0.5. So, all dimensions in figure are given in millimeter. So, if we try to solve this problem, then it will be clear to us. Say, in this problem the figure is given like this, say it is a ISWB 350 is connected with a bracket and it has a force F, this is F, and it is situated at a distance of 180 millimeter. Now, bolts are placed in this way, 6 bolts are placed with a pitch distance of 60 mm and edge distance of 40 mm. Right. So, this is bolt number 1, this is bolt number 2, and this bracket thickness is 12 mm and this is ISWB 350 section. Now, here we are using HSFG bolt, 8.8 grade bolt, right, and diameter of the bolt we are considering as 20 mm and mu f was given as 0.5 mm. So, if we want to solve this problem, what we will do? We will first try to find out proof load, because this is a high strength friction grip bolt. So, due to friction we have to find out the load carrying capacity. So, proof load we can find out F0 as ANB into 0.7 FUB, right. So, ANB we can find out as 0.78 into pi by 4 into d square, d is 20 mm into 0.7 into FUB is 800 in this case, right. So, this will be 55 into 10 cube Newton or 55 kilonewton. This is one. So, proof load we can find out as 55, sorry, this is coming 137 kilonewton, this is coming 137 kilonewton. Now, we have to find out the slip resistance. So, slip resistance of bolt can be found as VDSF is equal to mu f Ne kh into F0 by gamma mf. So, this if we put the value, mu f is considered as 0.5 and if we assume this as 1 and F0 we have calculated as 137 kilonewton and gamma f is 1.25 considering soft bolt. So, sorry, gamma mf is 1.25. So, if we consider, then it will be 55 kilonewton. So, VDSF value is becoming 55 kilonewton and strength of bolt in bearing, because it may fail due to bearing also. So, we have to find out the strength of bearing VDPB, that we can find out as 2.5 kb dt fu by gamma mb, right. Now, we have to find out the constant kb, which will be least of E by 3d0, that means E in this case we have considered 40 mm and 3d0, d0 will be 22. So, this is coming 0.606 and P by 3d0 minus 0.25. So, that is coming, P is considered 60 into by 3 into 22 minus 0.25, this is coming 0.66 and FUB by FU is 400 by 410, that is 0.975 and 1. So, list of these 4, 0.606, 0.66, 0.975 and 1. So, kb value we can consider, as 0.606. So, now we can find out the value of VDPB. So, VDPB value if we calculate, we will get VDPB as 2.5, KB is 0.606, D is 20, T is 11.4. This is 11.4 because the thickness of flange of ISWB 350 is 11.4, which is less than 12. So, lesser of the two thickness, that is lesser of the bracket plate and the column flange. Column flange thickness is 11.4 and bracket thickness is 12. So, least of these two we have taken as 11.4. Now, if we put this value, we can get as 113 kilonewton. So, bolt value we can find out as list of bearing and shearing. Shearing is 55 and bearing is 130. So, it will be 55 kilonewton, right. So, bolt value we could get. Now, we have to find out what are the bolt reaction is coming due to external moment, external force and its moment. So, here R1 we can find out. R1 will be, R1 means if we see here, this is one bolt, this is another bolt. So, if we consider this R1 will be this distance square plus distance square and its square root. So, this is 50 square plus 60 square of square root of this. So, this is 78.1 millimeter, right, 78.1 millimeter, because this is 50 and this we have considered 60, right, and R2 will be this one, R2 will be simply 50 mm. So, summation R square means summation of all R square will be 4 R1 square plus 4 R2 square. So, we can find out the value of this summation of R square, sorry, 4 R1 square plus 2 R2 square. So, 2 into 50 square. So, this is becoming 29398 millimeter square, right. So, now the force due to direct load in each bolt will be Fa is equal to P by 6, right, and force due to moment Fm1 will be P into E is 180, this is moment, by summation R square, that is 29398 into R means 78.1. This is Fm1 means bolt number 1 which we have marked at the extreme end. So, that is coming 0.478 P. Similarly, Fm2 we can find out as P into 180 by, that means M by summation R square into R, 29398 into, in this case R will be 50. So, this will be 0.306 P. So, here the bolt is this. So, we are providing in this direction one and in this direction another one. So, we have to find out the, this is bolt number 1, and in this case for bolt 2 this will be Fm and this is Fa. So, we have to add it, right. So, here theta 1 will be tan inverse 60 by 50, right. So, it is 50.19 degree and theta 2 will be 0. So, Fr1 means resultant force on bolt 1 I can find out as Fm square plus Fa square plus 2 Fm Fa cos theta, right. So, if we put this value we will get 0.478 P square plus P by 6 square plus 2 into Fm is 0.478 P into P by 6 into cos theta, cos 50.19, right. So, after calculation we can get this as 0.599 P, right, 0.599 P, right. Here let me tell you that Fa we got, assuming that all bolts are sharing equal loads, Fa will got P by 6, because number of bolt are 6. So, load will be shared as P by 6. So, now again Fr2, because we do not know whether in bolt 1 or bolt 2 will be maximum. We do not know, because here it is adding, Fm and Fr is adding, but Fm say 2, and here it is adding in a vector form, means in a resultant it will be Fm1 and Fa. This Fm1 and Fm2 is not same, this is more and this is less. Again here directly we can add, but here we have to get resultant. So, without calculation we will not be able to see, means we will not be able to predict which one will be more. So, we have to find out Fr2 also. So, Fr2 we can find out in this way, that Fr2 we can find out that 1 by 6 in 1 by 6 P by 6 whole square plus P by 6 plus 0.306 we got P, right. So, if we add these two we will get 0.473 P. So, Fr value will be the maximum of, means maximum force will be maximum of these two, Fr1 and Fr2. So, this will be, if we calculate, we have seen that after calculation these values are basically Fr1 was 0.599 P and that is 0.473 P. So, this will be 0.599 P Fr, right. So, now we can find out, we can equate with the bolt value. Bolt value we have obtained as 55 kilonewton. So, 0.599 P is equal to 55 we can equate, and then we can find out P as 55 by 0.599, and this will become 92 kilonewton. That means, to withstand the load on this arrangement of bolt, we need, means we can apply maximum value of P as 92 kilometer. 92 kilometer at a distance of 170 mm. I think 180 mm. At a distance of 180 mm, we can provide this. So, this is how, if we know the distribution of bolt and the loading distribution, then either we can find out the load considering the maximum capacity of bolt due to shearing and bearing, or we can apply certain load and we can check whether the existing bolt means in what way it is distributed are safe or not. Means if we provide certain load, then we can check what is the load coming on each bolt, or in the critical bolt what is the load coming, and that load If it is more than the bolt strength, then it is unsafe, otherwise the bolt is safe. So, this is how in other way we can do, either of the way we can do, either we can find out the critical load, or we can find out whether the section is means the connection group, bolt connection group is safe or not. So, in this way the calculation can be made when the eccentric connection, in a sense that load is lying in the plane of connection. If it is, then I can find out the section whether it is adequate or not. Section means bolt group, whatever it has been distributed is adequate or not. Thank you very much.